All right, piecewise functions, question number 3. We're going to write this absolute value as a piecewise function. First, we need to decide the breaking point, so when this is equal to 0, and we're going to have x minus 1 is going to be our breaking point. So if we rewrite our function here, hx, it's composed of two different lines. We're going to have at minus 1 here. The graph to the right is going to be x plus 1, so this is in the form y equals mx plus b. M is the slope, so the slope here is 1. So if for every 1 we go across, we'll go up 1, but we need to be starting with a y-intercept of 1. So our graph will look something like this. And so we can write this as a piecewise defined function, so it's going to be just x plus 1 for x bigger than minus 1. And of course, the absolute value graph also continues to the left in an upwards direction, but this is a negative slope this time. So to write that in our formula, it's going to be negative for x, and our y-intercept, if we imagine, would be at minus 1. So we'll say minus x minus 1 for x less than or equal to, let's say, 1. And it didn't matter if we put the equal to in this second function or the first function, since they intersect at the same point there anyway. Another way you could think about this is you have the minus value of x plus 1 for this second function here. So if we look across here, the difference here is we now have some extra terms outside the absolute value. So again, we can see here that the breaking point would be this time at 2, x equals 2. So when we write g of x, we'll have two different functions here. X equals 2 is going to be important. If we consider the positive value, well, that would be if we remove the absolute values, x minus 2 plus x minus 1. Well, if we group our like terms, we have 2x minus 3. So that's going to be our first function, 2x minus 3, when x is bigger than 2. So from 2x minus 3, if we start from minus 3 going across 2 every time, minus 3 and across 2, up 2, up 2, up 2. So from this point onwards, we can join our graph here to the right, and then we can consider the negative values. So if we have minus x minus 2 plus x minus 1, well, this would be minus x plus x, well, that's 0, and we have now positive 2 minus 1 is going to be 1. So our second function is going to be 1 for when x is less than or equal to 2. So from this value onwards, just a constant function of 1, which is a horizontal line. Bit wavy there, but that can be ignored. It's just a sketch. And this value will be included in one or either of the functions there.